I wanted to show you all a quick histogram. So if you highlight any data set, so I'll just highlight the basin flat area, and you go to Insert Chart. And I kind of really dislike that Google Sheets thinks it knows what I want. So it comes up with, this crazy line chart that is, and if you didn't know like where to change this, it would be really frustrating. So anyway, you can change it by going, whoops, close out the chat for a second. Line chart, and it's going to give you some suggestions. You just scroll down. Now there is histogram here, which is what I want, but I'm not sure if it's showing that to me because it knows me or why. You never know with computers these days. If you go down to other, you'll see histogram chart. So I'm going to click that, and now we have what's called a histogram. All right. I do not like the way they label the axes because they label them wrong. Just to get your bearings, down here is the horizontal axis or the y-axis. I mean, sorry, the x-axis or horizontal axis. And this is the y-axis or the longitudinal axis, or vertical axis, sorry. So you can double click on that, and we can rename it as we should. I'm going to rename it frequency. Okay. So now we actually, and I would also want to get rid of this little title because I don't like it. But what we see here is something you all are familiar with, even if you haven't had stats ever, or maybe it's been a long time. But what you have here is the beginnings of something that looks like a curve, a bell curve, right? A normal curve. If you could kind of imagine a curve going through this data, it would come up and go down and trail off. You'd have two little tails on the side. Now, of course, because of the way these columns are stacked, it's not perfect. It's never going to look like a perfect bell curve, right? But this is showing a normal distribution right here, where most values, most cacti are between 3.5 and 4.5 meters tall. Some are from 4.5 to 5.5. There's a few very tall ones and a few very short ones. It's a normal distribution, okay, that these students identified. So let's go back here and talk a little bit about the normal distribution. It's called the bell curve because it looks like a bell. I guess it does look a little bit like a bell. But it's more formally known as a normal distribution because it's very common in nature. It is a typical distribution for all sorts of things like blood pressure and height and all sorts of things you can measure in the natural world. So it's very useful. It's also known as a Gaussian curve. I just want to put that in there because the mathematician that originated this was named Gauss. He was a German mathematician. So some fancy people will say, oh, do you mean a Gaussian curve? And you can roll your eyes, but you will know that is just a normal distribution. Good to know the different terms people throw at things. Again, frequency with a histogram always goes on the y-axis or the vertical axis, and your label, and in this case height, if this was looking at height, would go on the horizontal or x-axis. If you were doing this yourself, not to beat a dead horse maybe a little bit here, but just to show you guys, the average height for men in the United States apparently is about 69 inches, which would be 5'9". So, the average, let's see this, if I can annotate, draw here. Okay, so this is the average. And if you went out and measured men of all around and got a sample, right? You would have come across most likely one or two in that range. Some would be closer, right? But you would stack these up in bins. Each X that I'm horribly drawing here is a data point. You'd have some that were shorter, right? On the tails, some that were really tall. But again, most measures would be in the middle. And if you filled this all out completely, eventually you would get that bell curve. And you might just study a sample, but as long as you get the bell curve at the normal distribution, you know the general status of male height. So that is the power of tying this to a normal distribution. All right, let me go back here. Okay, lots of things, like I said, in nature have normal distributions. Female shoe sales, I guess 8 to 8.5. If you drew that curve, you know, that's the most common size. According to this one data set, I don't know where it came from. I'm not citing my sources. I'm maybe being a bad example. I'm sorry. But anyway, this is just for, you know, showing you guys an example. Shoe size, IQ. Again, don't get me started on IQ measures. They are not a good measure in many ways, but they are also a normal distribution usually. And what's really cool about this figure, you see all these percentages and things. What this is showing you, this line is the average IQ score, okay, for whatever population was sampled, okay? 68% of humans are going to have an IQ within one standard deviation above or below that mean, okay? So this part here is one, I'm just gonna try to write, oh God, standard deviation below the mean, and this is one standard deviation. Some teachers watching this like, oh God, he doesn't know how to properly annotate, perhaps. So anyway, so that's really cool. So if you know the standard deviation and the mean, right, you know where 68% of the data falls with a normal distribution. And if you go 2 standard deviations, which would be here and here, you actually are capturing an additional 14%, another 14%. So you're at, these are rounded up, you're at 95%. You know where 95% of the population is in this area here. So that's really cool, and can tell us some interesting things. So let's go continue along. Before we get, you know, too far into normal distribution and thinking it's great, there are other distributions. There's the bimodal distribution, so it's like 2 humps, it's like a camel. If your students have a grade distribution that is bimodal, that's probably not good. That would mean your students some of them are really struggling, and a whole group of them are really struggling, such that they are very different than this group that's doing well. So most grade distributions with classes on scores and things are going to be a normal distribution, but if you saw this, you would be a little bit concerned if you saw this in your histogram. Let me look at the chat, because I see there might be some questions. Okay, so yeah, if you guys need to leave at any time, I know it's around dinner time for some of you on the East Coast, and some of you are getting out of work. I know that. You can always just exit. There's a leave meeting at the bottom right, but I am just getting into the good stuff. So, but there will be the recording, certainly. A histogram, I think I did have a definition somewhere in here earlier, and I will get into that. It's either I already covered it or it's in there. There's a definition there somewhere. But basically a plot showing different groups of data, the frequencies of them. Okay, and I saw someone raise a hand, but I do appreciate if you, instead of me trying to navigate giving you guys audio access, if you raise a hand, please just post it in the chat and I'll do my best to answer. All right, Thank you for the comments. Some of you guys giving some nice comments. Again, I'm glad if you're following along and catching with this stuff. Poisson distribution. This is actually very common in ecology. It's basically like a normal distribution, except like one tail is long and the other tail is super short. So this could be in a situation, like one example I might use is like overfishing of certain fish, like tuna fish, that they've found they're not finding the really large varieties of tuna so much anymore. They've been overfished from the oceans. So you might see a trailing tail at the higher end of size. And what that would mean is that those very large tuna are very rare. Someone's got a tuna joke perhaps up there, but hopefully not. In any case, so there's lots of examples like that where either very small things are rare or very large things are rare, and that would be a Poisson distribution, okay?